All right, guys. So we're going to talk today about functions. We're going to do a little review that will be useful for calculus. So I'm going to try to focus on just the concepts that you will need throughout this calculus course. So firstly, let's say what is a function. So you want to think about a function as a rule that will transform or that will assign every element in a set called a domain. This is where the function will be defined, and it's going to be sending this x into an f of x. And now the key aspect of a function is that to each x there is a unique f of x. So you cannot have something like this happening, that this would be sent to two different things. If that were to happen, that is going to be a relation, but it's no longer a function. We don't care about that. We don't want that. So to each x, there will be a unique f of x. And you have been familiar with the graph of functions. So let's write one typical function. So you have f of x equals x squared. So what does this do? Well, what this function does is it grabs any number that you feed it. Let's say you feed it a 1. And that 1 is going to be squared. So that's going to give you 1. Now, if you feed it a negative 1, remember, whenever you're going to plug any number into a function, use your parentheses. So negative 1 squared is going to be negative 1 times negative 1, which is going to be positive 1. Okay? And so forth and so on. So I always like to joke and say, well, what if I feed it a smiley face? Well, whatever you feed it, the domain would have to be in the domain, but just for sake of argument, you would have to square your smiley face. Doesn't matter what you're feeding it. You could feed a y, and that's going to just do y squared. Now, more importantly, however, is the fact that we can choose or feed expressions of this form, and that's going to be useful for us. And what you would have to do is use your parentheses, put that x plus h, and then square it. Now, you could FOIL that out, and I'm going to FOIL it just because I want to remind you that when you FOIL a binomial, you're going to square the first one, you're going to square the second one, and most people forget the middle term, which is going to be the double product of the two terms. Do not be the person that forgets the middle term. It's actually the most important term whenever we do calculus. So, at least when we take derivatives. So that is what a function, or roughly what a function will do. It's going to grab an x, give it an f of x. It's going to be unique. And we tend to be interested in graphing functions. So with what we did here, we could put that in a coordinate axis, except for this point and this one. But whatever. We're going to go ahead and try to graph this function. So let me go ahead and erase here, and I'll be right back. So let's say that we want to graph this, and we usually will do it on a coordinate axis. That's going to be the story of our lives for the next semester or next term, when we're going to be doing graphs over and over and over, but that's okay. So if I look at these points, this point right here corresponds to a value of x. That's a 1. So you go to your x-axis, you go to 1, and now you got to look for the value of y. The value of y is going to be this one right here, is what the function spit out. So I'm going to go to 1, and I'm going to mark that point 1, 1. That point will be on the graph of the function. I also graphed this point. Whoop, good catch. This point right here, where I had x equals to negative 1. So I'm going to go to negative 1 for the x. And you bet I'm not going to edit that one out. That's a good catch. Would I have dropped it, I edited it out. And you mark the point, negative 1. And the y value, it's a 1. Let's do a couple more points. Easy enough to do f of 0. Oops, wrong marker. F of 0 is going to be 0 squared, which is still 0. So that point at x equals to 0, I get a y equals to 0. That's the origin. And so if we plug one more point, I'm not going to write it because I'm out of space, but if I grab x equals to 2, when I put 2 in here, I get 2 squared, which is 4. So 1, 2, 3, 4, roughly here. perfect scale. Not, but you know, we'll get an idea. And then for -2, when you plug -2 in parentheses, you square it, the negative cancels, you get 4 again. So, but this graph is symmetric, as you all probably already know. But just in case there was anybody who was distracted in the pre-calculus class, we're doing this. Our graph goes like that. So let's go back to what we said. Oh, it's crooked. Oh, well, it's okay. No, it's your phone. Just rotate your phone a little bit. All right, so let's go back to what we said about the 1x getting only one f of x. What that translates to is if I pick an x here and I draw the vertical line that goes through that x, the graph should only touch the line one time, or none, but at the most one time. And that's what is going to be called the vertical line test. If a graph of an equation, let's say, touches the graph more than once, then that graph does not correspond to the graph of a function. Let's take a look at an example. All right, so let's say we have the circle, the unit circle, your favorite. And yes, a little off, but for my standards, this is fabulous. You could frame it if you will. So you have x squared plus y squared equals 1. Now, from our previous discussion, if you throw a vertical line here, well, doesn't touch the graph at all. That's fine. Doesn't rule out it possibly being a function, but if you draw this line here, you have two intersections, meaning that this could not be the graph of a function. And that is, if you solve this here, you would see why, because if you subtract x squared on both sides, you get y squared is equal to 1 minus x squared, and then you have to take a square root, but you get two possibilities, plus and minus, or square, or positive and negative, the square root of 1 minus x squared. So what that tells you is that to draw this graph, you need two functions. So one of them will be the positive square root, which is going to take all this upper semicircle. That's going to be the positive square root, and then the negative, which is going to take the bottom part of the semicircle. So that couldn't be written as a function, but we could write it as two functions. Sometimes you cannot even solve it at all. So that is what we have right now. So function, what is it? Is a rule that assigns for each x, it assigns one and only one f of x. And how can we check for that? Vertical line test. So if you have a vertical line that touches more than 1 point on the graph, that graph simply cannot be the graph of a function. All right, now we also talked about quickly how we can plot graphs. At the moment, we will just be plotting points. In pre-calculus, you would have learned other techniques, such as doing transformations. We're not going to worry about those at the moment, because I just want to lay down the foundations that you will need for your calculus course. So we're going to go very accelerated, but we're going to try to cover most of our bases. So the next thing we're going to talk about is the domain of a function. I think that this video is probably good right now. I'm going to start this next topic, the domain and the intercepts, in the next video. So thank you for watching, and I'll see you in the next one.